This might be the easiest lesson in this unit because it's going to seem very familiar. It's using a regression equation. So we've already used linear regression, log, exponential, power, all this kind of stuff. We're now going to use a sine regression. Okay, so this is coming up with an equation of y equals sine x. All right, so to do that, we're just going to put this data in the calculator the same way we've always done, and then figure out what the regression is. So let's get my calculator out. You guys can pause the video if you want and do this yourself. Okay, so I'm going to go to Stat, Edit, and I'm lucky it's blank right now. So I'm going to go 0, 45, 90, whoops, be careful that you don't make a mistake like I just did there, 90, 135, okay, so I've got the first column in, and then okay, so data is entered. Now what I need to do is go here. I'm going to clear this, turn my plot on. Okay, and I want to graph this. Okay, so I'm going to go zoom 7. Sorry, I used trig. I should go zoom there. Okay, so you can see what it looks like. Let's before I do the regression equation, I just want to quickly talk about how to graph that. Okay, so it says here, enter the values in the calculator and then use the sine reg to find the equation. That's great. Then it says to sketch the graph. Okay, so how do you do that? I mean, you can see that the picture looked something like this. Okay, I don't want you to graph like that, though. Anytime you're asked to graph, actually use the data that it gives you. So, you know, it says we're going from 0 to 360, so create yourself a scale here that looks something like this. Okay, and then it goes up to 10, and it goes down to -10, and then actually use the points. Okay, so we have at 0, 0, at 45 degrees, we're at 7. And then at 90, it's 10. At 1, okay, so you're actually using points here. I don't want you to just kind of guess where these points go. They go very specifically on the graph in very specific locations. Okay, and now if you wanted to, here you could sketch this. All right. And interestingly, you could probably figure out A, B, C, D, right? What is A? A is 10. What is D? It's 0. What is C? It's 0. And B, if you would go 360 divided by 360, you get 1. So you could write an equation, y equals 10 sine x. Okay, but let's see if we can actually do it using the calculator. So how do you do that? Well, we'll go to Stat, Calc, Okay, and we're looking for sine regression. There it is, sine regression. Enter. Okay, again, L1, comma L2. Enter. There it is. Okay, so what did it say? It says y equals, now look at what A is, 9.95. Okay, 9.95 sine. And then B is really, oh, wait, 1 second. Okay, so the B value looks a little strange because the one we did, we said B was 1, and this one it says B is 0.17. The reason for that is the calculator figures this out in radians, not degrees. So it did not use 360 here. Okay, it went and said 2 pi divided by 360. And that's where you get the 0.1, is it 0.17? Yeah, like that. That's where they get that. Okay, so that's fine. That's what we'll enter here. We'll take the calculator at its word. Now, what is C? C is negative 9.8 times e to the negative 4. That's a really tiny number. Okay, I'm going to say that's almost 0. Okay, why am I saying that? Well, if we go negative 9 times 10 to the negative 4, this is negative decimal 0.0009. Okay, for our graphs, since we're always rounding off to like 1 decimal, we're going to leave these as 0. Okay, so good enough. Let's go to the next one. Okay, following table shows the height of a person on a Ferris wheel over a period of time. Sketch a graph by plotting the points. Okay, so time, we're going to go up to 11. Okay, so if we want to divide this up a little bit, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, and then the height, what's the highest height? The highest height is about 31. Okay, so I'm just going to do this roughly. Here's 30. Here's 15. So at time is 0, height is 2.2, so let's put that there. Then at 2.5, it's going to be at 13.9. Okay, and you could be as, as accurate as you want it to be with this. There's 31.2. Then at 7.5, it's 25.4. At 9, it's 13.2. And 11, it's 2.4. So those aren't exactly the same, but you can see this is still a sinusoidal graph. Okay, it looks something like that. Okay, then approximate the equation. Okay, so what we have to do is we have to look at what is the highest and what is the lowest value. Well, if we go from 2.2 to 31.2, this is a space of 29. Okay, so that means our amplitude is half of that. Amplitude is 14.5. So let's put in some values here. A, B, C, D. I know the amplitude is 14.5, and if we go 14.5 up from 2.2, that gives you 16.7. So our middle line here is at 16.7. Okay, and we always write that as an equation, y equals 16.7. Okay, the period, don't overthink this. We're going to say the period is 11. So let's go 2 pi divided by 11. And if I put that in the calculator, 2 pi divided by 11 is 0.57. And then C. Well, C is a little bit tricky. I'm going to do something a little bit different here. What I'm going to do is I'm going to say, let's go to the highest point where it goes down. Okay? And I'm going to say that the highest point is at 5. Okay? Well, maybe the highest point is actually supposed to be at 5.5 because that's in the middle of 11. Okay? That's your cosine graph. Remember the cosine graph is this one? We're not as familiar with that one, but the highest point starts at 0. Okay, so if we now say the highest point has moved over 5.5, I'm going to say that. And why do I do that? Because I think it's easier than figuring out what this point is, how far that's over. I mean, you could estimate that as well, but to me this time it's just easier to do it this way. So here's my equation. You can use cosine instead. Okay? All right, now we could have done this all with a calculator. This time it asked us to do it by hand. We could have done it with a calculator. Okay, expect to have to do it both ways. What do the parameters A, B, and D represent? Okay, well, this says it's the Ferris wheel, a height. So 16.7 is, that's the D value. 16.7 is the average height. Okay, A is how far it goes from that. It goes up 14.5, down 14.5. So what this tells me is the highest value is about 31.2 meters, and the lowest is 2.2 meters, about. Okay? These questions are not going to, get mad if you're a little bit off there, but that's what we're saying. We're approximately highest and lowest values. Okay, what does B mean? Okay, B is 0.57, 0.57. That's probably not as important as what is 11, which is the period. Okay, the period is 11 seconds. It tells us it takes 11 seconds to go once around. Okay, so we'll say that. It takes 11 seconds to make one revolution, to go once around the Ferris wheel. Okay, how high are you at 8 seconds? Again, if we put this in the calculator, it would be fairly easy to do. But for us, we're going to go here and we're going to say this is approximately what? Well, we know that at 7.5 it was 25. This is a little bit lower. I don't know, do you want to say 22 feet or 22 meters? Okay. As long as you're showing where that answer comes from, not too serious. When do you first reach a height of 15? Well, that's right here. That's going to be, well, we know at 2.5, or sorry, 2.5 minutes, it was 13.9, so I don't know, what do you want to say, 2.7 seconds? Is it 3 seconds? 2.7 seconds. And what we'll do is we'll put this little symbol here. This means approximately. Okay, according to my graph, it looks like about that. Your graph might look different. If we put this all in the calculator, then we would use our calculator to find those points. Okay? All right. Let's do this one with a calculator. So this time, instead of doing it by hand, we're going to all put it into here. So let's go over to Stat, Edit. Okay. So so should we use Yeah, I guess we'll use months. 3, 4, 5, 6, 7, 8, 9, 10. Okay. Okay, so this is -16, -13. Average temperatures. I wonder if it's going to be this cold this year, because the temperatures have been pretty good so far. Make sure you're not typing these numbers in blindly. What I would do is right here, I would look, stop 10, yeah, that is 5. Okay, and then -5, -13. Okay, so what do? We go to zoom 9. There it is. Okay, but it wants us to write an equation to represent the data, so now that we've got it in here, we'll go to Calc, and you have to find the sine regression. There it is. Okay, and I'm going to go L1, comma, L2. Okay, there it is. Y equals 18.4 sine, then 0.4, I guess I should put 0.48. Okay, x minus, now it's negative, so this is going to turn positive, 1.8. And then plus 1.3. I guess we should stay consistent and go to 2 decimal places. There. Okay, so that's the equation. And then it says, what is the average temperature for the year? Well, how do you find the average? Okay, well, there's a couple of ways we could do this. If you think back to, I don't even know what grade that would be, grade 7, you could take these temperatures, add them up, and divide by 12. That would be one way. But let's think about what we're dealing with here. We're dealing with a sinusoidal graph. We know that the midline is 1.34. So it's going up and down from there. The average temperature is 1.34. Okay? I guess we should go degrees Celsius. All right, I'm going to skip example 4. I don't really like this one. It's kind of a forced question. And I would like you to try example 5, okay? So pause the video right now and give this a try. Okay, so I've entered the information into the spreadsheet, or the 2 lists, and I've graphed it. So you can see, you don't have to sketch this, but you can see that it looks like it's going to have 2 bumps like that. Okay, but the question is not, it's not asking us to graph it. It's not asking us for that. It says his friend Yale was in a building directly across from the Singapore Flyer at a height of 400 feet. When was Geordie at that height? So you can see that this goes up to 541 feet. If this building over here is 400 feet, they want to know when is it the same height. So how are we going to do that? Well, you could guess this. You could graph by hand. You could kind of come up with a good estimate. But I think here's the best way to do it. Let's first of all come up with the equation for this graph. Okay. So I'm going to go L1. Oops. Okay, I don't need to write it down, it's not asked for that, but I'm just going to paste this into y equals. So we'll go y equals vars 5 equation, enter. So it's pasted. So now I'm going to graph. Oops. Why is it doing that? Why do you think it's doing that? So why is it giving us a strange looking graph like that? Well, here's why. Remember in an example a little while ago, we had that issue with the degrees and radians not matching up? Your calculator defaults to the radian when it writes the equation. So this equation you see here is in radians. Okay, but if you look at my calculator, I'm in degrees. So let's put the calculator to radians for all of the calculator questions. Okay, now look what happens when I go zoom 9. There is my equation with a really nice fit. Okay, so maybe this is worth putting here somewhere. Use radians for sinusoidal graphs. Okay, that should be a reminder to you. Now, what were we asked to do? We were asked to figure out when is this graph going to be 400. Well, here's the easiest way to do that. Go to another graph and just say, let's have a graph of y equals 400. Okay? And you can see that this person is on the Ferris wheel at a height of 400, 1, 2, 3, 4 times right here. So what I'm going to do is I'm going to go to intersect, and I'm going to pick one of those places. Okay? Let's find one of the places where it's at the same height. Okay? So remember, you got to do the left bound, right bound thing. Okay? Actually, we don't. I guess we do in this case because it crosses in 4 times. So I'm going to say enter the first one, enter the second curve, guess. Okay, it gives me the first one. X is 11.84. I believe you should be able to figure out another one if we go a little further here. Okay, let's try intersect again. Okay, so here I'm going to say let's go here. So enter the first curve, enter the second curve, and guess. And you can see it gives me a different one. Okay, I don't care which one you give me. So again, let's just pick the first one. Intersect. Okay, I'm going to go and say I want the first curve over here. So go enter, enter, and enter. So it gives me that it is at X is 11.8, and that's minutes. So at 11.8 minutes, it'll be 400 feet high. Okay, again, there is more than one answer there, but I would say just take the first one. Okay, at what time was Jordy at a height of 500 feet for the 5th time? Okay, 500 feet. When do you get up to 500 feet? Well, this is 541 at the very top. So let me do this quick sketch again. So when are you going to be at, this is 541 feet. When are you going to be at 500 for the 5th time? There's the first, there's the second, there's the third, there's the 4th, there's the 5th time. When does this happen? Okay, well, let's change y equals. Let's say we want 500. Okay. So where is that 5th time? Let's see. Well, it looks like it's off the screen. So what I need to do with my window is I need to just make the X max go a little further. Let's go to 120. Let's see if that's going to be enough. All right. Now that 5th time is there, so let's go to second intersect. And let's go and put this cursor somewhere around that 5th time that it reaches there. So let's put it there. So yeah, go enter, enter, enter. And it looks like it'll be at the 89th minute. Okay, 89.0. Yeah, you can go 89.1, I guess. 89.1 minutes. All right. Here's your assignment, assignment D. If you could get that done for this assignment.